did something very similar with their 400 plus internal documents and policies. Instead of expecting call center agents to be walking encyclopedias of bank policies, they gave them an AI assistant that they could instantly pull up accurate information on credit limits and account policies. But here's where the story gets interesting. As we moved into 2024, we saw this dramatic shift in confidence and capability. The industry started moving beyond these controls internal applications. Rocket Mortgage is a perfect example of this evolution. They're not just using LLMs for back office efficiency, they're putting them right in front of customers. This was something that would have made financial institutions nervous in 2023 due to concerns about hallucinations and accuracy. So what changed? Well, these companies figured out sophisticated ways to mitigate risks, implement validation checks, and ensure security. They're not just deploying the technology, they're deploying it responsibly. We're seeing the emergence of multi-agent workflows, where different AI systems work together, each serving as a check and balance on the others. This progression tells us something about where we're going. Financial institutions aren't just asking, can we use this technology anymore? They're asking, how can we use this technology to transform our customer experience while maintaining trust and security that our industry demands? It's a remarkable shift from those early days of post-call analytics and document QA to today's sophisticated customer-facing applications that are reshaping how our financial services interact with their clients. And data analytics capabilities are evolving as the industry use cases grow in their complexity. A modern data architecture, which is the focus of my presentation, but I'm going to get into these multi-agent orchestrators towards the end, is the principal means of delivering on these promises. And building those modern capabilities on AWS, we enable security and build trust through every step of the process. Modern data infrastructure has evolved to mirror the simplicity of everyday digital experiences while maintaining enterprise-grade security and scale. First, data discovery has been reimagined to feel as intuitive as shopping on Amazon.com. Second, data governance isn't just about control, it's about establishing trust. Third, data sharing has transformed from simple file transfers to sophisticated collaboration. Modern platforms enable seamless, secure data across organizational boundaries, enabling teams to work together while maintaining strict security and compliance standards. So, let's start with the data lake. Well, whether we're talking about data lake, data mesh, or any other architecture, these are going to be the key components of focus. Of course, your data ingest, processing, storage, and analytics, all under the umbrella of good data governance. AWS data lakes create, and I regret I can't share this presentation. I'm sorry. So if there are images here, maybe you can contact me by email lately, but go ahead and take photos. There's a lot of information in this, and I am reading, but I swear to God, I wrote every word, okay? I did this just for Domino. So AWS data lakes create a central foundation where your organization's data comes together. At its heart, Amazon S3 forms the core storage layer where structured data from business applications, semi-structured data from sources like mobile devices, video, and audio can all find a home. Companies bring this data in through various databases, batch processes, or real-time streaming services. Once your data lands in the lake, AWS provides tools like Glue, Lake Formation, and Data Zone to catalog, secure, and manage it. The real power comes when you're ready to put that data to work. You can analyze it using services like Redshift or QuickSight, or apply machine learning with tools like Domino, SageMaker, and Bedrock integrations. This unified approach gives organizations flexibility to collect data from anywhere and transform it into valuable insights that drive innovation and better decision-making. Let me walk you through this modern data lake architecture implemented on AWS. We're handling data from multiple source systems, traditional on-prem databases, file systems, vendor files, and real-time streams, including Salesforce and Bloomberg. The ingestion layer leverages purpose-built services, such as database migration service for structured data, data sync for file transfers, AWS transfer family for SFTP requirements, AppFlow for SaaS integrations, and MSK for streaming data. The core of our architecture follows the medallion architecture pattern with three distinct layers: raw, processed, and consumption. We're using AWS Glue Data Catalog for metadata management, Lake Formation for security and governance, and Data Zone for data discovery and sharing. ETL processing between these layers is handled by AWS Glue jobs. For operational queries, we've implemented a transaction query layer using Aurora, RDS, and DynamoDB, which feeds back into our raw layer as needed. The analysis layer is segmented by use case. For fraud detection, we're using Neptune for graph database analysis, coupled with SageMaker and Bedrock for machine learning capabilities. Risk management combines EMR for large-scale processing with SageMaker and FinSpace for financial analytics. Standard reporting leverages Athena for ad hoc queries with Redshift and QuickSight for BI workloads. Finally, we're implementing comprehensive data sharing capabilities using Data Exchange, Redshift, and Cleanrooms for secure cross-organization capabilities. This architecture provides us with the flexibility to handle diverse data types while maintaining governance and enabling various analytical workloads at scale. This architecture closely mirrors what FINRA achieved in their transition from Oracle to AWS. They moved from a traditional data warehouse approach to a scalable cloud architecture for market surveillance, first with OATS and then with CATS. FINRA's event-driven architecture for intelligent document processing represents a crucial extension of FINRA's data lake capabilities, addressing the unstructured side of regulatory compliance. While their core system handles billions of market events, this solution tackles equally critical document-based regulatory requirements. Consider Form U4 processing. Every broker-dealer must submit these forms containing 20 years of employment history, education, and residential information. These typically arrive as scanned PDFs, which get ingested into S3. From there, the system leverages Textract for OCR to digitize the content, followed by Comprehend for natural language processing to extract meaningful relationships and context. What makes this particularly powerful is how it feeds into Neptune's graph database, or Neo4j, creating an interconnected web of relationships between representatives, their supervisors, firms, and trading events. The graph structure is invaluable for detecting patterns that might indicate compliance issues or fraud, whether that's insider trading, money laundering, or financial crimes. The architecture's event-driven nature means it can automatically process new documents as they arrive. This real-time processing capability, combined with the relationship mapping, gives FINRA unprecedented ability to detect suspicious patterns across both structured trading data and unstructured document content. So now let's explore how financial organizations are moving beyond data lakes. Leading financial institutions today are implementing data mesh architectures to reflect how data naturally flows across the organization. This decentralized approach is particularly relevant in financial services where different domains have different interests, such as trading, compliance, risk, or customer service. Consider how this works in practice. A trading desk might own and process market data products, while compliance teams, like we saw in FINRA's use case, manage regulatory reporting data products, and risk teams maintain credit risk data products. Each domain takes responsibility for the quality and governance of those data products, but they can share them securely across the organization. This domain-oriented ownership model is crucial for financial services because it maintains a clear data lineage for regulatory compliance. It enables specialized teams to apply domain-specific quality rules and allows data sharing while maintaining regulatory boundaries, and supports cross-organizational data sharing through governed interfaces. Intuit's data mesh implementation showcases how a modern financial technology company can balance decentralized ownership with centralized governance. Their architecture flows naturally around producers and consumers while maintaining strong data stewardship and self-service capabilities. What's particularly interesting about this approach is their sophisticated handling of data domains. Rather than strictly aligning with business units, these domains flex to match real-world data relationships. Take their payroll services, for example. Product Area A maintains complete control over its customer company data, as you'd expect. However, when it comes to individual customers who might interact with Intuit products, they've implemented centralized data mastering in their universal data domain. This hybrid approach makes it perfect sense in a financial services context where you need consistent customer profiles across products while still allowing individual business units to maintain autonomy over their product-specific data. Fannie Mae transformed their data architecture by implementing a data mesh on AWS, moving away from a monolithic approach that created siloed data and slow time to market. They adopted a hub-and-spoke model where business domains operate in separate accounts while maintaining centralized governance. Using AWS Data Sync, S3, and Zero ETL for real-time ingestion, they achieved faster data access times and improved time to market and scalability for petabyte scale operations. Service that makes it faster and easier for customers to catalog, discover, share, and govern data stored across AWS, on premises, and with third-party sources. Administrators and data stewards who oversee an organization's data assets can manage and govern access to data using fine-grained controls to ensure that it's accessed with the right level of privilege and in the right context. DataZone enables a truly modern data mesh architecture by facilitating seamless interactions between data producers and consumers while maintaining robust governance. All right, I'm only going to cover these very briefly, but Amazon Redshift has something called Amazon Redshift data sharing. It enables you to share data within and across an organization, across AWS regions, and with third-party providers without moving or copying the data. AWS Data Exchange enables customers to easily find, subscribe to, and use third-party data in the cloud. And AWS Clean Rooms enables secure external collaboration. So those are the three principal tiers, very quickly, in a nutshell, with a lot of service names that we use to talk about and to develop and grow both our data lake architectures, and there's nothing wrong with data lake, but the more modern approach, which is data mesh. So now let's get into what everybody only cares about. Predictive AI is still 90% of your workloads. I don't have to tell you that. But the bottom line is that agentic workflows and customer-facing applications are what is happening right now in 2025. And we're beginning to see for the very first time the cost-benefit barrier being broken finally with generative AI. So let's dig into this. I'm going to walk you through three compelling examples of multi-agent architectures that are revolutionizing financial operations, particularly interesting for those of us who are working on machine learning systems and data pipelines. First, we'll look at Bridgewater's sophisticated approach to investment research. They've developed a hierarchical multi-agent system to tackle complex economic analysis questions. Their architecture includes a data retrieval agent, a causal mapping agent that constricts relationship graphs between economic variables, and a data mapping agent that connects these causal nodes to Bridgewater's internal databases. Parameta has implemented an equally impressive system integrating Bedrock flows with an agent architecture that automates email responses about trade executions. The third case is Athene's transformation of their insurance customer data integration. So here's an AI investment analysis system at work. When a user asks about interest rate effects on markets, their question triggers a collaborative intelligence process. The planner first maps an analytical approach, which the supervisor then distributes among specialized experts. Data Finder retrieves market histories. Coder runs statistical models, and Web Searcher gathers current economic analysis, all working in concert and in parallel. The synthesizer then weaves these findings into cohesive insights, delivering a comprehensive response about interest rate impacts on growth, inflation, and market returns. There's nothing here about tariffs. This seamless collaboration transforms a complex question, although it might be there now, into structured economic analysis through coordinated efforts of specialized AI agents sharing their distinct expertise. Now let's consider a more sophisticated AI investment analysis system addressing how interest rates affect markets. Upon receiving a complex economic question, the system initiates a structured three-pronged approach under a central plan. First, a causal mapping process establishes the interconnected economic relationships, tracing how short-term interest rates influence the yield curve, economic growth, and equity valuations, and ultimately both equity and bond returns. This theoretical framework establishes the analytical foundation for understanding market mechanisms. Simultaneously, a data acquisition process matches specific economic inquiries to appropriate data sets. Short rates for interest rate changes, real GDP and economic growth measures, headline CPI for inflation tracking, and specialized metrics for equity and bond excess returns. This ensures analysis is grounded in relevant empirical evidence. The third parallel workflow, the system generates analytical code for visualizations, translating complex economic relationships into statistical models and intuitive charts that reveal historic patterns between monetary policy and market performance. This demonstrates how multi-agent approaches transform a complex economic question into qualified insights by coordinating specialized analytical functions, creating a comprehensive investment intelligence bridges between economic theory and empirical market data. Parameta's AI system transforms client email processing through a streamlined workflow. When a client like John Smith requests financial data verification, the system immediately classifies the message as a price verification request. There we go. Key information is automatically extracted and structured into JSON format, capturing essential elements such as product type, ticker, date, request type. After validating this data, the system queries relevant databases using precisely formulated SQL to retrieve the requested information. Finally, a professional response email is generated confirming the verification, providing relevant context, and maintaining an appropriate business tone. At Athene, a retirement services and annuity reinsurance provider, we implemented Amazon Bedrock to address critical inefficiencies in data processing. The process begins with all relevant data and the legacy code files being uploaded to the data lake. When a user initiates the process by requesting generate the mapping document, this triggers the first LLM workflow. The LLM then performs three key operations in sequence. It determines the fields, analyzes file dependencies, and generates the mapping the document. Once complete, this mapping file is automatically stored back in the data lake. The second part of the workflow shows how the system handles queries. The data lake feeds into a knowledge base, which connects to another LLM instance. Users can ask specific questions about the implementation, such as how cash surrender values are calculated, which files are involved in the calculations, or how certain features are labeled in the new model. The LLM, drawing from the knowledge base, can provide accurate contextual responses to these technical questions. Looking at the sample output, we can see exactly how Athene's AI solution works in practice. On the left side, we have the mapping document, which serves as a clear transition guide between the old and new systems. It systematically shows how variables from the original Python code connect to the new data model fields, while also documenting which source files are involved in creating each field. This transparency is crucial for maintaining data lineage. The right side of the output reveals the interactive capabilities of the LLM system. When asked about cache surrender, value calculations, the system provides a precise technical response, explaining both the calculation methodology and identifying the specific files involved. Now, customer-facing applications have unique challenges. First of all, you're facing the customer. The operational aspects of this are very human in nature. There's a lot of history in every company in how they should be handled. There's cultural, geographical, and company culture differences that need to be included in designing these systems. Now, it goes without saying, security and governance really overrides almost every consideration before anything could go into production. Those include data security controls, regulatory compliance, responsible AI, as well as we can define it today, and prompt injection attacks. So some of the companies that have done this well, and just because of the limitations of time, I'm not going to go into as much detail on these, but these are all available on AWS as public use cases. So I encourage you to either contact me directly or to look up what we have on the site. Remitly and Rocket Companies and NatWest Group are all providing customer-facing, multi-agent Gen AI applications right now. Okay, so how do we help enable this on AWS? We have a product called the LLM Gateway. The LLM Gateway and almost the philosophical approach we've taken at AWS from the very beginning was to support all of the foundation models on Hugging Face, as well as our own in-house models, and now including Gemini and OpenAI. I know everyone in the room is using OpenAI, so let's talk about it. The LLM Gateway architecture serves as a united interface for accessing multiple AI model providers through a secure, scalable AWS infrastructure. This implementation uses Light LLM, an open source project, as the core technology to provide the gateway functionality. The architecture begins with client traffic flowing through Route 53, the DNS endpoint, protected by an AWS firewall against web exploits, and distributed through application load balancers to containerized workloads running in either ECS or EKS. At its core, the system leverages container orchestration through either ECS Fargate or EKS, with images stored securely in Amazon ECR. The central Light LLM service, along with its API middleware layer, handles request routing, model access, and integration with various AWS services. That includes Bedrock for native AI services, external providers like OpenAI, Anthropic, and supporting services such as Elasticache for caching, RDS for configuration persistence, and S3 for logging. Security is implemented through multiple layers, starting with identity management through IAM roles and RBAC policies, network security through VPC isolation and security groups, the data protection using encryption at rest and in transit. The system employs AWS secrets managers for credential security and implements comprehensive monitoring through CloudWatch. Cost management is carefully considered through multiple dimensions, including LLM provider costs and AWS infrastructure expenses. The architecture allows for optimization through caching strategies, compute resource scaling, and efficient traffic management. Key cost factors include instance sizing, storage requirements, auto-scaling configurations, and network transfer operations. The system provides administrative capabilities through a web interface for user management, API key generation, and model testing. It supports advanced features like budget controls, rate limiting, and usage tracking across organizations. The implementation includes AWS-specific enhancements such as Bedrock integration, managed prompts, and support for Okta OAuth 2 authentication. Operational considerations are addressed through high availability design, implementation of proper logging and monitoring, and maintaining security through regular updates and vulnerability assessments. The architecture supports both development and production workloads with the flexibility to scale based on demand while maintaining security and cost controls. Last but not least, I want to introduce you to Agent Squad. Agent Squad is an open source project developed on AWS that is a multi-agent orchestrator. It's on GitHub. It was originally called the multi-agent orchestrator. And here's just generally how it works, very similar to what we saw in our prior diagram. But as my closing comments here, I'm just going to let it run. And we're seeing here, and I sped up some of it, as you begin this conversation, you're talking to a travel agent. And then we move on to, what's on the plane. We're still sort of in travel agent mode. But then because this is in a multi-agent orchestrator, we can move around among highly disparate domains and move into what's the square root of 10 plus sinus over 19, not necessarily a travel agent's question. And so you get the idea. So this is literally just off of the rack if you just git clone off of the Agent Squad GitHub. I still call it multi-agent orchestrator. A really powerful way to get started with multi-agent orchestration. Okay, so that's all I had to share. And I know I went fast, but I wanted to kind of share a lot of different ideas. Domino is obviously handling a lot of this above the hood for you, but this shows you a little bit more of what's going on. And this I know about my 30 years of doing ML. It's all about the data. Modern data architectures are a key to creating high-value applications. Once you have your data architecture settled and you're in a relatively good production mode, then it's all about inference. Because no matter how much fun it is to create new models and to discover new things through our data science expertise, 70% of your time, or 80%, is still on getting the right data, formatting it quickly and easily enough, and then keeping the inference costs down. That's still the problem. LLMs didn't fix that. So thank you very much.